In this section, or actually the next two sections, we're going to look at what we call conic sections. So if we look at the diagram up here, a conic section is the intersection between a conic and a plane. And when we talk about a conic, what we're talking about is this cone that you see here, where it's actually two cones. And there are two cones that share a common point or vertex. In this particular diagram, we have a cone that's facing down and a cone that's facing up. And that's our conic. The conic are those two cones. Now, if you intersect a conic with a plane that's slanted and just passes through like the rim of either the upper or the lower cone, then you will get the shape of a parabola. We've talked about parabolas, but now we're going to look at them in a different way. So a conic section is just a curve that you get when you intersect a plane with a conic. And we've seen parabolas. In the next diagram, we've seen circles. So that would be when you intersect, in this case, it's a conic that is upright. So if we intersect it with a horizontal plane, what we'll get is a circle. So depending where that plane intersects, you could have a circle with a really tiny radius or a very large radius. Same with the parabola. You can have a parabola opening up, or if it happens to intersect at the bottom, you could have a parabola that opens downward. Now the conics don't have to be upright like you see here. They're just conics in three-dimensional space. They could actually be on their side. If they are on their side, what you'll get is you'll get parabolas that don't open up or down, they open left or right. The other two, the ellipse and the hyperbola, those are going to be discussed in 8.2, but I'm kind of combining both sections at once. Now, ellipse and hyperbola you might not be familiar with. An ellipse is similar to a circle. You'll have this plane that intersects either the upper or the lower part of the conic, but it's a little bit slanted. So it does pass all the way through, but since it's slanted, what you get is an oval. And then the last one would be the hyperbola. That's the last one we're going to talk about. That would be when you intersect, and it actually intersects both the upper and the lower portion of the conic. As you see here, it looks like what we're getting is two parabolas. So it's like a hyperparabola, which we call a hyperbola. Now in this box here, I have the standard form of all the equations of the conic sections that we're going to look at. Parabolas may be a little bit different than what your book has as a formula. So we're just going to be looking at vertex and center pretty much for all of these conic sections. But in your book, they also talk about other properties as well, like foci and directrix. We won't be discussing that here. So the first thing we're going to look at is our parabolas, and that should be familiar to us. So we're going to have two types of parabolas. We're going to have parabolas that are horizontal, and those would open left or right. They're not functions if they open left or right. Or vertical parabolas. So that's what you're used to from Math 135 or from your prior algebra class, because those are the parabolas that open up or down, and those are functions. So we have discussed those previously. So if you have a horizontal parabola that opens left or right, what you're going to see is you're going to see the x is not squared, but the y is squared. And that tells you it's horizontal. And when we say horizontal, we kind of think of the x-axis, which is a horizontal line. So if the x is not squared, it's a horizontal parabola opening left or right. Vertex is going to be HK, And the h is usually associated with the x value. K is associated with the y value. If the a in front of the parentheses y minus k squared is positive or greater than 0, then it's going to open right. Negative, it opens left. Now the parabolas that you're used to seeing are where you have the y by itself and the x is squared. So if you can write the parabola in this standard form, it's easy to identify the vertex hk. And if a is positive, it opens up. Negative, it opens down. The next thing we're going to look at is circles. Again, I know you guys know the standard equation for a circle. That would be the x minus h squared plus y minus k squared equal to r squared. So in this standard form, you could see the center, hk, and the radius, r. So these, besides a parabola that's opening horizontal, the vertical parabola and the circles should be familiar to already. So let's look at our ellipse and our hyperbolas. So ellipse, going to have two cases, and same with hyperbolas. As with parabolas, with an ellipse, you're either going to have horizontal or you're going to have vertical. Same with hyperbola, horizontal or vertical. And again, when we say horizontal, that has to do with x-axis. So an ellipse that is horizontal means it's going to stretch out parallel to your x-axis. And in the standard form of the equation, that means that the number that you have in the denominator underneath the x's is going to be larger than the number you have in the denominator under the y's. So in an ellipse, you could tell if it's stretched out horizontally or vertically by the largest denominator. So again, largest denominator under the x stretches horizontally. And with an ellipse, the equation is, standard form of the equation is equal to 1. Center, hk. The a value is larger than the b value, and they're both positive. They're not negative. So vertices. To find the vertices, since it's stretched out horizontally or parallel to the x-axis, since we're stretching it out horizontally, we're going to add and subtract the a value from the h value. So that's an x value. The k value, which is a y value, stays the same. So we're only changing the x value. And we'll look at how that applies to a graph in just a little bit. This is a little bit abstract and kind of hard to understand. But if you do have an ellipse that has a vertical stretch, that means the largest denominator is under the y. Okay, smallest denominator is under the x, equal to 1. So center is still hk, a greater than b, both positive, but the vertice, since the largest denominator is under the y and it stretches out vertically, when we find our vertice, we're changing the y value and adding and subtracting that a value. So it's h, k plus and minus a. Hyperbola, horizontal, it's going to open left and right. And unlike the ellipse, when we talk about the hyperbola, instead of having a plus in between, it has this minus. So it doesn't really matter in a hyperbola which denominator is larger, not like the ellipse. What matters is what comes first in the subtraction. In a horizontal hyperbola, the x comes first. Again, doesn't matter the a squared or the b squared, which one's smaller and which one larger. It just matters which comes first in the subtraction. If the x comes first in the subtraction, and again, this is equal to 1 like the ellipse in standard form, then it's going to open left and right, center is hk, and when we find our vertices, since x is larger and it's horizontal, then we change or adjust our x value or our h. So h plus or minus a will give you the x values of your vertices. The k value, which is a y value, stays the same. So vertical hyperbola opens up and down. That just means that in the subtraction, y comes first. Again, it doesn't matter which is larger, A or B. If the y is first, it's a vertical hyperbola. Center is still hk. So you notice the center is hk for all of them, except for the parabolas where vertex is hk. And since the y comes first, we're changing the y value in the vertices. X value stays the same. So I know that's pretty abstract when we just talk about it. So let's look at some graphs and see if we can identify these values hk, a and b, and so on. So let's look at these examples. This first example, notice the x is by itself, but the y is squared. So that tells me that it's a parabola, and the graph is a parabola. And since it's x and the y is squared, it's a parabola that's either going to be opening left or right. Notice that this negative in the front, that's our a value. So the negative is like a -1. So since a is negative, this parabola should be opening left, and I could see by this diagram that it does open left. This 3 is our k value. The k value is always next to the y. And this 2 is our h value. So remember, in a parabola, hk is going to be our vertex. Here's our vertex. Is that 2, 3? So just notice that on the axis, it goes 0 and then 2. So if I go to 2 and go up, this is 3. So yeah, it looks like the vertex is at the point 2, 3. So this would be my H and this is my K. Okay, and this opens left. Let's look at our circle. Again, I know this is review. So the 2 is my H. Careful, this is a +1. So the K value is a -1. So how you want to think about this is what y value will give me 0 in the parentheses. And if y is -1, then you get 0 in the parentheses, so that's your k value. Now remember that 4 is r squared. So that means r is equal to 2. Let's look to see if we have the center 2, -1. And yes, we do, because this is -1. And then if you notice, the radius here is 2, because we can go 2 units out in all directions, vertical and horizontally, and we get our circle. So we have radius is 2, center is 2, -1. Maybe I'll write that down. And maybe I'll put these values here for the parabola as well. So remember, we have our vertex is 2, 3. Okay. And it opens left. Maybe that would be nice to put down in words. This next example here, this is an ellipse or an oval. Notice that the x comes first. So that means, notice that the 9 is larger than the 4. So that would mean that since the 9 is underneath the x and the 9 is larger than the 4, it's the largest denominator, then this is going to be stretched out horizontally or parallel to the x-axis, and it is. So this would be my a squared, which means a is equal to 3. And then also look at my h value, which is 1. My k value is -1. So that means I should have a center at 1, -1. So we'll go to 1, we'll go to -1, and yeah, that looks like the center. So maybe I'll write this down here, center 1, -1. So what about these vertices? So the vertices in ellipse are the longest distance from the center. So if it's stretched out horizontally, then your vertexes are stretched out as well horizontally. Sometimes this is called the major axis. And then the distance from the b values, or in this case, the up and down 2 and -2, that would be the minor axes. But let's find our vertices. So remember what we're doing here. What we're doing is we're changing our x value. We're adding and subtracting our a value from our h value. So if we take h plus a and h minus a, that will give us our vertices. H is 1, a is 3, so h plus a would be 4. And h minus a would be -2. So let's go to 4 on the x. Y value is still -1, that didn't change. And -2 on the x, the -1 for the y value hasn't changed. So that makes sense with the graph that the vertices are going to be at -2, -1, and 4, -1. Here's another ellipse, but this is stretched out vertically or parallel to the y-axis, which is a vertical line. Notice that the denominator 16 is the largest denominator, and it's underneath the y value. So that would be our a squared, which would mean a is equal to 4. Our h value is -2, and our k value is 1. So our center is -2, +1. Is that right? -2, +1. Yeah, that seems to make sense with the graph. Oops, let me move this around a little bit. Okay, so center -2, 1. What about vertices? So we're looking at stretched out vertically. Notice that when we go up and down from the center, which was -2, 1, we're changing the y value, but the x value of -2 stays the same, which means my vertices will be -2, comma something. So here's a vertice down here. And -2, comma something. Oh, that got dark. How we find those somethings is we take our a value of 4 and we add and subtract it to our k value. So if k is 1, then k plus a is equal to 1 plus 4 would be 5. And k minus a is equal to 1 minus 4, which would be -3. So let's see if that makes sense with our graph. This should be a 5. And this should be a -3. And it is. So -2, 5, -2, -3. The last shape we're going to look at is our hyperbolas. Now remember, in a hyperbola, it matters what comes first in the subtraction. So here, since the x minus 3 squared, or the x comes first in the subtraction, that means that this is going to be a hyperbola that is horizontal. Okay, so let's see. Center is h equal to 3 and k equal to -2. So let's see what that looks like. 3, -2, there you go. So you notice that the center for a circle, an ellipse, and a hyperbola, it's not actually on the graph. The center in all three of them would be represented by a distance. So the center in a circle has, if you go from the center to the circle itself, you're going to have that radius, that same distance all the way around. In an ellipse, the center corresponds to the largest distance from the vertices. And in a hyperbola, the center corresponds to the shortest distance from the vertices. So if you look at this hyperbola, the vertices are the innermost points, so they're the shortest point from the center. And since this is horizontal, it means that to find our vertices, we're going to change our x value. So first of all, this center, which is 3, -2, that makes sense with my picture. I just have to find the vertices. So I have to take my a value. So the a value is underneath. It doesn't have to be the largest value. It's just the one underneath the first in the subtraction. So in this case, a squared is equal to 1, which means a is equal to 1. So I'm changing my h value. I'm going to add a, and I'm going to minus a. So h was 3 plus 1. I get a 4. And then 3 minus 1 gives me a 2. So are the vertices at 4, -2, and 2? So 4, yep, and then 2, -2. That's right. So let me write that down for reference. Center is 3, -2. Vertices would be 2, -2, and 4, -2. And our last one, y comes first in the subtraction, so this is going to be a vertical hyperbola. I have to figure out what these vertices are, and I have to figure out where the center is, but I could see from my, remember this is a k value because it's next to the y. K is -1 and h is 2. So it looks like my center should be 2, -1. Let's see, 2, -1. Yeah, that's correct from the graph. Okay. Now my a is 4, or a squared is 4, sorry. So a is 2. And my k value is going to change for my vertices, so it's going to be k plus a, which is equal to -1 plus 2, or 1. K minus a, -1 minus 2, which is -3. Do those values make sense? So remember, our x is the same. We're changing our y value. So it should be 2, 1. Yeah, that looks right. And 2, -3. Looks good. So those are our vertices. And these are our 4 conic sections. So what if you don't have a graph? What if you just have an equation? Well, in that case, you have to complete the square, get your equation in standard form to be able to identify the conic section. In example 1, oh, we did all of this, and this is our first example. I see this horribly long equation. What I do notice is that I have an x squared and a y squared. So that tells me this is not a parabola, because remember, in a parabola, you'll have, if y is squared, x is not. If x is squared, y is not. So at least I know this is not a parabola. So it's going to be a circle, a hyperbola, or it's going to be an ellipse. Now, it's probably going to be a circle or an ellipse, because I see that there's an addition between the x squared and the y squared. Remember, hyperbolas have subtraction, but I won't know until I get this in standard form. So what I'm going to do is I'm going to put my x's together. So I get a 9x squared, and then the minus 36x plus 16y squared minus 64y. And then this minus 44, I'm going to add that to both sides. So I'm just moving it to the right to have it equal to a positive 44. Now that I have the x's together, what I want to do is I want to complete the square on the x's. So if I group 9x squared minus 36x, and I group 16y squared minus 64y, it's going to be easier for me to see how to complete this square. The first thing I want to do is get this square by itself. So notice in our first set of parentheses, there's a 9 in front of the x squared. I need to factor that out. So remember, I'm dividing the 36 by 9 as well to get x squared minus 4x plus, and in the second set of parentheses, there's a 16 in front of the y squared. So I'm going to factor that out to get y squared minus 4y. Now looking inside these parentheses, I have to ask myself, is that a perfect square? No. Well, how do I get a perfect square? So remember, completing the square, you take half of the negative 4 and you square it. So that's the same as negative 2 squared, which is 4. So if I add 4 inside the parentheses, I will have a perfect square trinomial. And then we look at the y squared minus 4. Again, that's not a perfect square. But if I take half of that negative 4, which is negative 2, and I square that, I get 4. So adding 4 inside the parentheses will give me a perfect square. Let's go ahead and add those in. I'll get 9x squared minus 4x plus 4 plus 16 y squared minus 4y plus 4 equal to 44. The problem is I can't simply add those numbers in on the left-hand side without also adjusting the right-hand side, because this is an equation. If I add stuff into the left, the equation's off, so I have to balance it again. But be careful. Although we added 4 inside the parentheses where we have the x squared minus 4x, we also have this 9 on the outside. So if you can imagine distributing the 9 and getting rid of the parentheses, we would get back to 9x squared minus 36x plus 36. So we didn't just add 4, we added 4 times 9, or 36. That's what we added in here. So I have to add that 36 to the right as well. Same goes with the y. Although we added 4, we actually added in 16 times 4, or 64. So I have to add the 64 on the right-hand side as well. Let's complete the square inside the parentheses. This becomes 9 parenthesis x. So remember, it's x minus 2 squared plus 16 y minus 2 squared equal to 144. Okay, well, I know this isn't a circle, and the reason why I know this isn't a circle is because the number in front of the parentheses is different. If it was 9 and 9, I could divide out by the 9 and it'll look like a circle. But since it's a 9 and a 16, that tells me that it's probably going to be an ellipse. So to write an ellipse in standard form, the first thing you want to do is get it equal to 1 after you complete the square. So I'm going to divide everything by 144. So all three terms. So the 9 over 144, that, let's see, 9 goes into 144 16 times. So this is going to be x minus 2 squared over 16. Plus 16 goes into 144 9 times. Equal to 1. That is a standard form of an ellipse. So if I were to identify, I would say this is an ellipse. So that would be identifying the conic. We also had to find key information like a center or a radius or a vertex. Well, in the case of an ellipse, you find the center. So the center is going to be the HK. So if I have x minus 2, my h is 2. Y minus 2 means my k is 2. Our vertices. So the 16 is the larger number. It's underneath the x. So that means I'm going to, and here notice that since a squared is equal to 16, a is equal to 4. So that means I'm going to take my center x value, which is 2, and I'm going to add 4, and I'm going to subtract 4. So if I add 4 to 2, I get 6. Y value didn't change. If I subtract 4 from 2, I get negative 2. Y value didn't change. So it's an ellipse, center is 2, 2, vertices are 6, 2, and negative 2, 2. So standard form, type of conic, and key information. So in class, we did not cover this last problem, but why not? So this is B. Let's see, I have a y squared and an x squared, so that tells me it's not a parabola. And I do see a subtraction, the y squared minus x squared. That tells me this is probably a hyperbola. But you never know until you write it in standard form by completing the square, because sometimes when you divide to get equal to 1, you could be dividing by a negative number, and that could switch the x squared and the y squared around. But it looks like a hyperbola where the y squared is going to come first. First step, I'm going to put all my x's and all my y's together. Well, actually, I'm going to put my, since I see it's y squared minus x squared, maybe I'll put my y squared plus 4y first, minus x squared plus 2x. And then we have our 6 is already by itself. So I'm going to group my y's and be very careful because of this subtraction. I'm factoring out a negative from the x squared plus 2x, so the x squared minus 2x. So there's a caution there. And now completing the square, I'm going to take half of 4 and square that, which would be 2 squared, which is 4. And that's what I'll be adding to my y's. Look at this though. There's nothing in front. So when I add this 4, I don't have to worry about multiplying it by some number outside of the parentheses. Now let's look at our x. we're going to take half of negative 2, which is negative 1, and then we'll square it to get a positive 1. We're going to add the plus 1 inside the parentheses, equal to 6. So you can imagine that outside of the first set of parentheses where the y values are, that there's a 1 there. So 1 times the 4 is just 4, and I'm adding 4 to the right-hand side. However, we have to be careful because we have a negative in front of the second set of parentheses. So although I added a positive 1 inside the parentheses, because of the negative on the outside, imagine if you were to get rid of the parentheses and distribute that negative, you would get a minus x squared plus 2x minus 1. So I'm actually minusing 1. So I have to do the same thing to the right. I have to minus 1. And then this becomes y plus 2 squared minus x minus 1 squared equal to 6 plus 4, 10 minus 1 is 9. So I see I have a subtraction, probably a hyperbola. Divide everything by 9 to get it equal to 1, same as what we did with our ellipse. And this becomes y plus 2 squared over 9 minus x minus 1 squared over 9 equal to 1. So this is a hyperbola because of the subtraction. And since the y comes first, it's going to be vertical, which means when I find my vertices, I'm going to be changing the y value, or that k value. We have a center at 1 comma negative 2. So remember, we put the h value, which is next to the x, first in the center always. So our vertices, if we change our negative to our y value by adding and subtracting, so a squared is equal to 9, a is equal to 3. By adding and subtracting 3 to the y values, we will have 1 comma negative 2 plus 3 is 1. 1 comma negative 2 minus 3 is negative 5. That's our equation in standard form. And this is the conic section along with key information. So that is it for these two sections.